Hello everyone. So today we're going to go over section 4.1, dividing polynomials by binomials. So we'll begin with a review of long division of integers. Okay, so we have here in the first example 2748 divided by 13. So let's set that up. Alright, so we'll write a 2 here, and then we have 2 times 13 is 26. And of course, we take the difference there, which leaves us with 148. Right, and then we simply have 1 for 13. And once again, we subtract, and we're left with 18. Oops, sorry about that. 18. And of course, another 1 will give us 18. Sorry, not 18, 13. And if we subtract again, we are going to be left with a remainder of 5. Okay. So we'll be doing something similar with polynomials. But before that, just one more example. So 806 divided by 7. Okay, of course, multiply by 1 gives us a 7. And then we can subtract. Left with 106. And we have another 1 here. 1 times 7 is 7. We subtract again. And we are left with 36. And 5 times 7 is 35. So if we subtract again, we have a remainder of 1. So quick aside here, we have this 0 in 806. So what is the 0 doing in that space? Okay, so if we were to think about it, 806 is really 8 times 100 plus 0 times 10 plus 6 times 1. Right, so the 0 in 806 means there are 0 tens. Okay, this will be important when we look at dividing polynomials by binomials. Okay, so moving on. So we're going to use the same kind of long division process for dividing polynomial, just like we will with numbers. So in the first example here, we have x cubed plus 4x squared plus x minus 2. And this will be divided by x minus 1. So let's go ahead and write that in. Right, so x minus 1 multiplied by x squared. See if we can color code this here a little bit. X squared will give us x cubed minus x squared. And of course, then we can subtract. 4x squared minus negative x squared will give us 5x squared. And the plus x minus 2, of course, carries over. Continuing on, the second term will then be plus 5x. Since the product will then be 5x squared minus 5x. So once again, we subtract here. And of course, x minus negative 5x will give us 6x and a minus 2. So the last term in the quotient will be a plus 6. Oh, sorry, this is the wrong color here. It's just easier to understand if everything is color-coded correctly, so let's just fix that. So 6x minus 2, and then of course we have 6x minus 6, the product of 6 times x minus 1. And if we subtract again, negative 2 minus negative 6 will give us a remainder of 4. Okay. So that's what we get when we divide. Let's do one more example here before moving on. So this time we have x cubed minus 4x squared plus 5x plus 1. Okay, once again we're dividing. So here we go. Before we begin, I'm just going to move this down a little bit so there's more space to write. Alright, so on the other side, of course, we have x plus 1. And similarly, x plus 1 times x squared will give us x cubed plus x squared. And of course, we take the difference. This will be negative 5x squared plus 5x plus 1. Then the next term would be negative 5x to give us negative 5x squared here. And this will be minus 5x. And once again, we take the difference. And that will actually give us 10x plus 1. So the last term of the quotient in this case would be plus 10. Gives us 10x plus 10. So once we subtract, the remainder would be negative 9. Right, so now that we have done some dividing, it is useful to write our answers as division statements. So in order to do that, let's go back to the numbers example. So a division statement would look like this. We have 806 is equal to 7 times 115 plus 1. And so the components of this, the first part is the 806. That is the dividend. Which is the number to be divided. We have 7, which is the divisor, the number that we divide by. The 115 would be the quotient, the result from the division. And of course, 1 will be the remainder. And the whole idea here is that if we take 7 and multiply by 115, we get 805. And then if we add 1, we get back 806. And so division statements for polynomials are very similar. So in this example here, example 1, the division statement will be x cubed plus 4x squared plus x minus 2 is equal to, and once again we have our divisor, which was x minus 1, our quotient, which is x squared plus 5x plus 6, and our remainder of plus 4. Okay, so very similar formatting. I'm just going to write down what that is once again. So again, dividend is equal to divisor. If it is a polynomial, probably put it in parentheses, and then the quotient also in parentheses if it is a polynomial, and plus the remainder. Now the order of the quotient and the divisor can be switched since multiplication is commutative. Okay, so let's do one more division statement, that is. Meanwhile, I just want to rewrite the remainder here, just to make it look a little bit nicer. So in both the examples, 1 and then the try example, the remainder is just a number. So in the first case, it was plus 4. And in the second case, it was negative 9. So that doesn't necessarily have to be the case. The remainder itself could be also a polynomial. It is entirely possible. But for now, we're just going to stay with the examples that we have where the remainder is just a single number. Alright, so the division statement in the last example here, this will be x cubed minus 4x squared plus 5x plus 1. The dividend is equal to the divisor of x plus 1. The quotient, which is x squared minus 5x plus 10. And in this case, minus 9, the remainder. All right. And so, moving right along, the next example is a little bit different. When we did the numbers example, we saw that in the 806 example, there was a 0 because there were 0 tens. So we're going to use that idea with dividing polynomials using 0 as a placeholder. Okay, so let's look at this example. So in this case, we have x cubed plus 4x squared. Notice that this cubic polynomial does not have a x term, so we will add plus 0x, and then we have minus 5. The reason for that is because notice that the binomial that we're dividing by has an x and then just a constant. So going from the first to second term, the degree is going down by 1. And so in order to make the dividend the same, we need this 0x term right here. So the exponent goes 3, 2, 1, and then, of course, 0. All right, let's divide. See what happens. Not going to color code this one. I think it's going to be okay. We have x squared. So x squared times x plus 2 gives us x cubed plus 2x squared. So the terms once again line up. Subtract those two. That'll give us 2x squared plus 0x. So the next term in the quotient will be 2x. That will give us the 2x squared that we need, and also plus 4x. There's supposed to be minus 5 here. All right, so, and then we subtract, and we're left with 0 minus 4 is negative 4, and then minus 5. So the last piece here, this will be minus 4. Okay, so that will give us the negative 4x, and also minus 8. Once again, we subtract here, and the remainder would be 3. Okay, so making a good habit out of writing the answer of these divisions as division statements. So we have, in this case, x cubed plus 4x squared minus 5 is equal to x plus 2 times x squared plus 2x minus 4, and then plus 3. Alrighty, so now question might be, is there a faster way of dividing, aside from using long division where we divide polynomials by binomial? And there is. There's something called synthetic division. And we usually use synthetic division for monic binomials of degree 1. So it doesn't have to be the case, but it's just much easier if it is. So for monic binomial of degree 1, so what does that mean? Well, monic means that the leading coefficient is 1. Binomials means that it has 2 terms. And degree 1 means the highest power of the x's is just 1. So in other words, it just looks something like this, x minus a. Okay. So let's look at how that works. We have here example 3a, 2x cubed plus 4x squared minus 5x minus 6 divided by x plus 1. Now, the first thing we need to find is, notice that x plus 1 is the same as x minus negative 1. And this negative 1 is what we're going to be using for synthetic division. So we'll write it here. And usually the next step is to set up a grid. So we'll do that. Something that looks like this. This would be quite sufficient. Now the next step is to write down the coefficients from the dividend. So in this case we have 2, 4, negative 5, and negative 6. Alright, so what happens next? Well, the first number, the 2, just gets moved down to the bottom. So nothing really happens to that. So here we'll just write 2. And then what we'll do is take 2 and multiply by the negative 1 that is on the left-hand side of the bar. 2 times negative 1 gives us negative 2. Okay. And so 4 plus, notice it's not minus, 4 plus negative 2 gives us 2. All right, now we do the same thing. So maybe just here, next number, 2 times negative 1 is once again negative 2. And once again, we'll add. So negative 5 plus negative 2 is negative 7. And negative 7 times negative 1 is positive 7. And so, negative 6 plus 7 is going to give us 1. So, now that we have some numbers at the bottom here, 2, 2, negative 7, and positive 1, what does that mean? Well, the first 3 here, that will make up the quotient. So the quotient is 2x squared plus 2x minus 7. And the second piece is the, running out of colors here. Maybe orange is okay. The 1 here is the remainder. Okay. So that's the process of synthetic division. We find the quotient and the remainder, which is, of course, what we need to find when we divide. Let's go ahead and try a second one. Just give us 1 second here. There we go. All right. Let's use different color. So in this case, notice that the terms are not written in the descending order. So the first term is actually 2, and then 5x squared, and then negative 1x, and then minus 6. All right. And also here, x plus 2 is really x minus negative 2. So the number that we're going to place on the left-hand side of the bar is negative 2. And from there, the process is the same. 2 carries down to the bottom, the first coefficient. And then we have 2 times negative 2, which is negative 4. Add together gives us 1. 2 times negative 1, sorry, negative 2 times 1 is negative 2. Add together gives us negative 3. Negative 3 times negative 2 is positive 6, and we have a remainder of 0. So x plus 2 divides 2x cubed plus 5x squared minus x minus 6 evenly, which is good. And of course, these results can be written as a division statement as well, as we will be doing in just a moment. But for now, we have 2x squared plus x minus 3 as the quotient, and a remainder of 0. Okay. Now, what if the polynomial in question is not cubic? What if it's quartic or even quintic? So in examples C and D, we'll examine those. Turns out it's basically the same. Okay, so again, we will sort the coefficients from highest to lowest. The highest power of x here is the 5x to the 4th power, so the first coefficient is 5, followed by 12, then negative 21, then negative 40, and finally minus 12. And again, just like before, x plus 3 is the same thing as x minus negative 3, so the number on the left is negative 3. So we have 5, then negative 15 here, add together gives negative 3. That means here we have positive 9, add together gives us negative 12. Negative 12 times negative 3 is positive 36. Negative 40 plus 36 is negative 4. And then multiply gives us 12. And of course, that means the remainder is 0. So the quotient is, well, 5x cubed minus 3x squared minus 12x minus 4. But if we were to write this as in the form of a division statement, we'll have 5x to the 4th power plus 12x x cubed minus 21x squared, and then minus 40x, and then minus 12, and that's going to be equal to x plus 3, the divisor, multiplied by 5x cubed minus 3x squared minus 12x minus 4, which of course is the quotient. All right, so one final example. Again, change colors. Right, very similar setup. Just going to change it slightly. There we go. All right. So again, we're going to write down to the terms in order. So negative 1 for the negative x to the fifth power. And then the 6. And then minus 11. Notice that there is no x squared term. So that would be a 0. There is no x term. That's another 0. And finally, the constant term is a 5. And just as usual, x plus 1 is the same thing as x minus negative 1. So the negative 1 will go on the left-hand side. All right, see what happens here. We have negative 1. Negative 1 times negative 1 is positive 1. 6 plus 1 is 7. Multiplied by negative 1 is negative 7. That will give us a total of negative 18. Negative 18 times negative 1 is positive 18. 0 plus 18 is 18. Multiplied by negative 1 again gives us negative 18 here. That will give us a sum of negative 18. And then it switches again to positive 18. 5 plus 18 is 23. So ultimately, it has a remainder of 23. So if we are once again to write this as a division statement, then the parts will be negative x to the fifth power plus 6x to the fourth power minus 11x cubed plus 5. And that's going to be equal to negative x to the fourth power plus 7x cubed minus 18x squared plus 18x minus 18. That, of course, is the quotient. It's going to write in the reverse order just to show us that it works. And then multiply by the divisor of x plus 1. And finally, plus the remainder of 23 in this case. Alrighty. So we've looked at long division and also synthetic division now. Just a quick note about the remainder theorem. This will be useful in the next section, so I'm going to go ahead and mention it now. It says when a polynomial p of x, so something that looks like what we have dealt with today, is divided by a binomial x minus a, so the format of monic binomial of degree 1, where a is an integer. That's what this means. Then the remainder is equal to p of a. So if we just need the remainder, we can simply substitute whatever a value of x minus a we're dividing by into the polynomial, and we can find the remainder that way instead of actually having to divide. So one quick example says here, example 4, when 2x cubed plus k x squared minus 3x plus 2 is divided by x minus 2, the remainder is 4. Determine the value of k. So using the remainder theorem, we're simply going to substitute 2 into the polynomial in question. And that will be equal to the remainder of 4. And the whole idea is now we can solve for k. So 2 cubed is 8. 8 times 2, is 16. 2 squared is 4. That will be 4k. Minus 6 and then plus 2. Simplifying those numbers there. combining everything on the left-hand side, that will be 4k plus 12 is equal to 4. So of course we can divide both sides by 4. That will leave us with k plus 3 is equal to 1. And k is going to be equal to negative 2. Okay. And there are, of course, other uses for the remainder theorem. There's a corollary that we'll look at, and that will allow us to factor cubic polynomials. But that's it for today, so thank you for listening.